Hello everybody, welcome back. We are on 5.2. I broke this up into a couple of parts. The first thing we're going to do is we're going to be multiplying radicals. Let's recall back to when you first started to multiply variables. Remember, when we have different variables, we multiply those separately. So for example, in the first one we have 2x squared multiplied by 3xy. So what we do is we multiply, obviously the x is gone now, we don't use that anymore, we use x as a variable, so that should be written as brackets. And remember, we multiply the coefficients, so the 2 multiplies by the 3 and we get a 6. We multiply the x squared by the x and we get x cubed, and the y is not multiplied by anything, well, multiplied by 1 I guess if you wish, and that becomes y. So the final answer is 6x cubed y. So here are your steps for multiplying radicals. We multiply the coefficients and then we multiply the radicands. And you can only, this is very important, you can only multiply radicals if they have the same index. So what that means is you can't multiply a square root by a cube root. It will not work. Okay? So we multiply the coefficients and then we multiply the numbers, the radicands. So basically multiply the number in front of the square root sign and multiply it by the number underneath the square root sign, or the radical sign, I guess I should say, because the cube roots are there as well. So let's look at the first example. We're going to multiply monomial radicals. So when we multiply a radical by a radical, so you'll have the square root of 3 multiplied by the square root of 5. That becomes the square root of 3 multiplied by the 5. So they come underneath one radical sign, and that becomes the square root of 15. And what you would do is you would simplify these if need be, but in this case the square root of 15 cannot be simplified any further. So we can't break that. That's an entire radical. It can't be broken down into a mixed radical. You'll see what I'm talking about in the second example, 1b. So we have 2 square root 3 multiplied by 5 square root 6. So we take the 2 and the 5, we multiply those together, it becomes 2 multiplied by 5. And then we multiply the square root of 3 by the square root of 6. That all goes underneath the radical sign, so that's the radicand. And that becomes 3 multiplied by 6. So 2 times 5 is 10, and 3 times 6 is 18. So our answer is 10 square root 18. So you'll notice that I've gone even further, and this is the simplifying. This is something we should do automatically, okay, even when it's not asked, because if it's a multiple choice question, the answer is not going to be 10 root 18. An equivalent answer is one that's going to be simplified, which you see at the bottom there is 30 root 2. So once we get to this point of 10 square root 18, you guys know how to do the rest. We've done that in 5.1. So 18, we know we can break that down into 9 multiplied by 2. 9 is a perfect square. We take the square root of 9, it comes out and becomes a 3. We take the 3 and multiply it by the coefficient of 10, and we get 30 root 2. Great way to check your answers. Again, we'll bring up the graphic calculator. There's a couple of ways we could do this. I like to do it 3 ways just to make sure. You don't have to do this every time, but it's a good chance to check it out. So we have 2 square root 3, and that's being multiplied by 5 square root 6. 5 second function square root 6, and we get 42.42. And remember, our final answer was 30 root 2. So 30 square root 2. Enter, and it's the exact same. So there you go. You know you're correct. Something I recommend doing, especially when you do them the first few times. It's just a quick check, and you're all set. The next example, C. We have a variable this time, so we have x root 2 multiplied by negative x root 6. So that x, the two coefficients multiply together and give us negative x squared. And the 2 multiplies by 6 and gives us 12, but we can simplify the 12 to 4 times 3. The 2 comes out when we bring it out front, and your final answer is negative 2 square root x root 3. And that can't be checked, obviously, because we have variables. Multiplying polynomial radicals. So polynomials that has more than one term, right? So this one here, it's root 2 multiplied by all in brackets 5 plus 2 root 3. So the square root of 2 needs to be multiplied by the 5, and it also needs to be multiplied by the 2 root 3. So the square root of 2 times 5 is just 5 root 2. 5 in front. And then the 2 root 3 multiplied by root 2 becomes 2 square root 2 times 3, which becomes square root 6, and that's it. We can't do anything further with that. That is simplified. Nothing to be simple. It can't go any further. Okay. Next one. 2 times 2 is 4. That's where the 4 comes from here. 6 times 3 is 18. That's where the 18 comes from. 2 times 1 is 2. And 6 times 10 is 60. And then we're going to break this down the best we can. So we know, remember, we just did it before. The square root of 18 becomes the square root of 9 times 2. The square root of 9 is 3. 4 times 3 is 12. So that simplifies to 12 root 2. And then the 60, the greatest factor, perfect square factor would be 4. 4 times 15. Square root of 4 is 2. 2 times 2 is 4. So we're left with 4 root 15. So there is your final answer right there. 12 root 2 plus 4 root 15. Okay. Then I have a couple of these harder ones here. With C and D, just follow your steps. Just because there's more variables involved doesn't make it any more difficult. But try to go through these and take a look at them and just do your best with them, right? Okay. So, like for example, in C, we have 3 multiplied by 1, so it's just 3, and we have 8c times 12c, all underneath one's radical sign. So 8 times 12 is 96. C times c is c squared. So we can take the square root of c squared to get the c out front. 96 breaks down into 16 times 6, so we can take the 16 out front. And take the square root of 16, we get 4. So 3 times 4 times c, and you're left with the square root of 6 is the only thing that could be left underneath the radical sign. So 3 times 4 times c is 12c, that's the coefficient, and we're left with the square root of 6 there. And then we do the same thing with the second half, so it would be 3 root 8c times 16. So the 8c multiplied by the 16 underneath the square root, we get 128c. 64 is the greatest perfect square factor in 128, so we got 64. Take the square root of 64, we get 8. There's nothing you can do with the 2 or the c, so that remains underneath the radical sign, square root 2c. 8 times 3 is 24, and we're left with 2c, and they can't be added together because they have to be exact same underneath the square root sign, which are called like radicals, and they obviously aren't. So this is your final simplified answer for question C. Okay, and you can work on D. It's an optional question. We don't need to do cube roots, but you can work on that, and it's definitely an extension, and I do recommend you give that a try as well. Let's move on to page 10. We multiply a binomial by a binomial, just like we used to do when we did the quadratics. These are done the exact same. So we do our first term of our binomial multiplied by the first term in the second binomial. Just a distributive property, remember? And then we have the first in the first binomial multiplied by the second in the second binomial. And then we do the same thing with the second in the first binomial by the first in the second binomial. And then the last term, the fourth, would be the second term in the first binomial by the second term in the second binomial. So it's the exact same method as we used to do with our quadratics when we learned to multiply a binomial by a binomial. So like x minus 3 multiplied by x plus 2. It's the exact same process, only now we're doing it with radicals. Okay, so square root 3 times square root 7 is square root 21, and that's simplified. There's nothing you can do. That's why I have it written here. The square root of 3 multiplied by the negative square root 5 becomes minus root 15. Again, that can't be simplified. And then we have the square root of 35 coming from root 5 times root 7. That can't be simplified. There's no perfect square factors of 35. And then 5 times 5 is 25, and it subtracts, so subtract root 25, and that can be simplified just to 5. And there's your final answer. Okay? Let's look at B, example 3B. Now this one here, we notice that it has a binomial squared. So in the first line, I've expanded it to a binomial multiplied by a binomial. So that was something we learned. Remember, we had x minus 2 squared. That was equal to x minus 2 multiplied by x minus 2. It's the same thing. Okay? And then I'm not going to go through every little process here. but you just do the exact same. First times first, first times second, second times first, second times second. So that is called the distributive property, where each term of the binomial gets multiplied by the other terms of the other two binomials, ending up with 4 terms. All right, and then the square root of 4 is obviously 2. The square root of 10 can't be simplified, but these can be added together because they're like radicals. So that's where the 12 root 10 comes in. 4 times root 25, square root of 25 is 5, and that's where the 4 times 5 comes in. So we have 18 and 20, which adds up to 38. And these are like radicals. Oh, sorry, right here. And there's your final answer, 38 minus 12 root 10. Or you could have written it as minus 12 root 10 plus 38. It's the same thing, right? Okay. Here's one that's a little more complicated for you. Just go through the process. I don't want to go through it with you. It'll take a while, but there's the final answer. Again, this is an extension. It's not a compulsory question, but it's a nice challenging one for you to do. Okay, and I just followed the same process as I did in the last 2 examples. So there you can give it a try, and there's the final answer that you see highlighted at the bottom. Okay, so give that one a whirl on your own as you're working through the examples. Okay. So there's the homework for 5.2 on the first part of which is multiplication. Just some suggested questions to work on from page 289, numbers 1 through 5. All right, thanks everybody, and we'll be back on page 11 when we're going to look at dividing radicals, which is a little more in depth, and we'll go from there. So thanks again, and we'll see you next time in 5.2, which is the dividing of radicals.